Welcome to all of you. In this session, we are going to execute an assembly language program of 8051 microcontroller. The program is write an ALP to move a block of n bytes of data from source, that is 20H, to destination, that is 40H, using internal RAM. So we are making use of the internal memory to move the data from source to the destination. So n can be any value. So in this uh, flow, we are going to take 5 as the value of n. So with respect to program, we are going to make use of 3 registers along with the accumulator. So register R0 is used to hold the address of the source memory, that is 0x0020H. R1 is used to hold the destination memory address, that is 0x0040H. Both are internal memories, and R2 is used to hold the count value. Now let us go through the program for this. Let us get into the program. So starting with the first instruction over here. So we are totally making use of 3 registers. So R0 as a source pointer, R1 as a destination pointer, memory pointer, and R2 as a counter register. So move R0 comma hash 20H. We are going to take the 20H as the source memory location. So first we are initializing the R0 with that memory location value. Then R1 with the destination memory location 40H. So this is as per the question. Now move R2 comma hash 05H. So we are taking a consideration that we are moving 5 values from source to the destination. So R2 will be the counter. For that purpose we are storing the value 5 to the R2. Now getting into the next part, that is the movement of the data from source to the destination. Move A comma at R0. The value present in the memory location pointed by the R0, the very first location, that is 20H, will be moved to the accumulator. Now move the content of accumulator to the destination, that is move at R1 comma A. Contents of accumulator will be moved to the destination memory location, which is pointed by R1. Now the first data has been read from the source and moved to the destination. We need to get into the next set of data. For that we are incrementing the R0, then incrementing the R1, so that source will be pointing to the next memory location, destination will be pointing to the next memory location. Then verify the register R2. So DJNZ stands for decrement jump on no zero R2 comma back. First decrement the contents of register R2. If it is not equal to 0, then get back into the loop once again. If it is equal to 0, then it will come out of this loop. So it is now loaded with the value 5. Just one value has been moved. Now it will have the value 4. That means still 4 values needs to be moved. Therefore it will move back into the loop, and the loop repeats until all the 5 values have been moved. That means the R2 becomes equal to 0. Once it becomes equal to 0, it will come out of the loop and the execution will be halted. Now let us see the same in the simulation in the Kill software. Now let us get into the simulation part. So the same program has been typed over here. Now let us start with the execution. So first, so build it in order to identify any errors. So no errors found. Get into the debug and then start the debug mode. So now we need to observe the memory location. So get into the view, then get the memory window. So memory 1 and memory 2, we need 2 memories, one for the source and one for the destination. And one more memory window, that is the memory 2. So I will be taking this in order to indicate the source. So since this is internal memory, I will type I colon 20H memory location, and this one is the destination. So I will type it as I colon 40H Right, as we can observe in both the memory locations the data are 0. Now I will feed this source memory with the data. So 10H, then comma 20H, then 30H, then 40H, then 50H. Total 5 data we are transmitting. We need to make a movement, so 5 data are being fed. So now we can observe all 5 data are available over here. Now let us start with the execution step by step. So F10 we can use for step by step execution. So now the execution is at this point. So move R0 comma 20H. Now registers are available over here. Accumulator is here. Now we need to observe R0 is being loaded with 20H R0. Presently it is equal to 00. Now let us make an observation of that. Now R0 is being loaded with 20. Continuation. So then R1 loaded with 40. R2 is now loaded with the value 5. Now make an observation. Contents of R0 in the sense, so R0 is having the value 20. Contents of that memory location in the sense the value must be 10H, that must be moved to the accumulator. So now the value 10 hexadecimal has been moved to the accumulator. Then after that data needs to be moved to the destination which is pointed by the R1, that is this memory location you have to observe 40H. So now it is equal to the value present in that memory location is equal to 0. Now let us verify is it going to update or not. So now as you can observe, now it has been updated to the value 10. So then increment R0, increment R1. It was pointing to 20 and 40 respectively. The next data need to be moved present in the location 20, location 21. In the destination it is 41H. So these two needs to be updated. So now it has got updated 21 and 41 updated. Then verify for the next content, that is R2. R2 is equal to 5. Now it has to verify with one decrementation. It has decremented by 1. Right? So similarly, I will just continue with the looping part. As you can observe, in each loop, the R2 is being decremented, source to destination, the data is being moved. Now this is the last data being moved. So now at this stage, R2 is equal to 1. Now if I execute, R2 will become equal to 0. After that, the execution will come to an end. So thanks for watching.